Hello everyone, I am Meghna from G356. Today I am presenting my milestone 2 project on porting LLMs to mobile devices and integrating office tools using large language models. This project focuses on how we can efficiently run large language models locally on Android devices and use them for smart task automation. We successfully integrated a LLM-based model directly into an Android phone using llama.cpp. This required compiling the model using CMake and the Android NDK into .sol libraries and linking them to Kotlin using JNA. We learned a lot about how on-device inference works, how prompts are tokenized, and how responses are generated, all without using the internet. We also built a stable bridge between Kotlin and native C++ code. One key achievement was fixing memory crashes during integration. By formatting prompts according to the model, we got better results. We improved the model response quality. We enabled smart actions like setting alarms or sending SMS by converting model outputs into JSON and triggering Android actions through intents. Coming to architecture evaluation, initially our architecture used a Tarmac server running on the device, and we want to access the model using a REST API from a React Native app. Features like calendar and Excel were handled through external libraries. We used a quantized Orca Mini 3B model and even handled voice commands. But in the updated version, we switched to native Android using Kotlin. The llama model now runs directly on the phone using llama.cpp, and we don't rely on REST APIs anymore. We integrated everything using JNI and Android NDK, and the current model is Llama 3.23b in GGEO format, which is more efficient. Now everything alarms, calendar, SMS calls is managed within the app itself using Android intents and Kotlin APIs. We made the app available through APK Mirror so users can download it without needing the Play Store. To install it, they just have to enable unknown sources in their phone settings. What is important is that this app works fully offline. The language model and the logic are bundled inside the app itself. There is no need for internet connectivity at all. Coming to challenges faced and model selection, we faced several challenges. First, debugging between Kotlin and native C++ was difficult due to limited logging in JNA. Second, we had to carefully select and quantize the model to make it run within 6 to 8 GB RAM, which is the limit for most mobile devices. Third, smaller models often gave unreliable or incomplete JSON outputs unless we used very careful structured prompts. We explored many models. They are Mistral 7B was too large for mobile use even with 4-bit quantization. Tiny models like Phi2 or Tiny Llama were fast, but they couldn't generate structured JSON reliably. Gemma 2B had limited support in llama.cpp. GPTQ and XLLama were not compatible with our JNI setup. Finally, we choose Llama 3.23b because it offers the right balance between performance and efficiency for mobile devices. One of the main advantages is that it supports fast offline inference. The model runs directly on the device using llama.cpp and JNI with no need for an internet connection. Key strength of this model is it understands and responds accurately to task-based prompts like setting alarms or scheduling calendar events. Its smaller model size makes it lightweight, which helps reduce storage requirements and keeps memory usage within the limits of most smartphones. Overall, Llama 3.3b fits perfectly into our goal of building an efficient, fully offline, intelligent assistant for Android. Coming to app functionalities, the main features of our app powered by the on-device language model. For SMS, the app can send a message when the user says something like send a message to Chandana saying I'm late. It uses Android's built-in SMS intent to send it. For phone calls, the app extracts phone numbers from what the user says and starts a call using Android's call intent. For calendar events, users can add events by just describing them naturally, like setting a reminder on Friday at 3 p.m. The app converts this into a calendar entry using action insert. For offline question answering, the app can answer general questions like what is the capital of France instantly and without internet. All processing is done locally by the model. For alarm, when a user asks to set an alarm, we don't use the phone's default alarm app. Instead, the app shows a custom notification at the specified time. The app supports voice input. It converts speech to text, sends it to the model, and gets the response. This makes it hands free and very user friendly. These are the code snippets of my app, and coming to demo of my Android app, it can understand natural language commands and perform actions like sending SMS, making calls or creating calendar events. Here, I'm asking the bot to send an SMS. It passes the request and sends the message using Android's built-in SMS system. It shows SMS sent successfully after send. Next, I asked the bot to create a calendar event for a birthday on August 28, 2026. The model responds by scheduling the event currently using Android intents. By clicking on the save button, the event is created. I also tested making a call. The bot identifies the number and triggers the phone dialers to place the call. Then I asked they send SMS using voice input. The model responds by sending the SMS to the user. All of this works offline and directly on the device using a compact version of LLM 3.2 3B integrated with Kotlin and C++ using JNI. This demo shows how powerful and responsive an on-device language model can be for automating everyday phone tasks. Coming to the architecture of my offline mobile application that uses the Llama 3.2 3B instructor model. The app supports both voice and text input. For voice commands, we use speech to text conversion. Once the input is received, it passes to the Llama model which runs locally on the device using llama.cpp and is integrated via JNI and Kotlin. The model is optimized and quantized to run efficiently within model RAM limits. Based on the response, the app performs specific actions. If it's a calendar command, it uses Android's intent system to create events. For calls and SMS, it uses SMS manager and call intents to send messages or dial numbers. For questions or general prompts, it simply displays the answer from the LLM in the app. The app can retrieve or add information to Excel sheets locally, allowing users to manage structured data offline, for example, storing notes, lists, or logs using simple voice or text commands. All these features, calendar, calling, messaging, and question answering, work offline, powered by the LLM running full on device. In conclusion, we built a fully offline assistant powered by a language model running directly on Android. It's fast, efficient, and capable of doing real tasks completely offline. Thank you.